like many collaborations, hopefully one with me also continuing. And we had a 7-day workshop and 4-day conference. And as you know, that this is a second activity at MS University. There was one satellite meeting of ICN on a similar topic in 2010. So in the workshop, we had about 25 participants and lots of speakers, Dani, Nadkarni, Siddharth Bhattacharya, Anish Ghosh, Vadim Kaimanovich, Vikarnan, Sejal and Ektasha. So, and I type all of them, and the topics covered were Ergodic Theory, entropy, number theory, topological dynamics, group actions on homogeneous basis, etc. Sorry, my phone is bad. And all these participants, I hope, learned something, and that helped them to go through these long sessions of conference patiently. I thank them all. And I would like to thank all the speakers of the conference and for giving such nice lectures and being patient. We had these long sessions without much break, 2 minutes, 1 minute, 3 minutes break. So and no break also now. So and especially François, Latrapier and Hello Strauss for putting extra effort and presenting Daniel's work in a good way, and we get gist out of it. And hopefully all the participants and everybody had a nice time. So I thank all the speakers for taking their valuable time off between Christmas and New Year, coming from far away to India and making this conference a big success. I think it's a success. And at this stage, I would like all of you to think about your contribution to the proceedings, and I invite you all to submit your papers to them. We are thinking of type with some journals or lecture notes, and we'll send emails in due course, but you don't have to wait for it. You can always start sending. So, and I would also like to thank RCTS for International Center for Theoretical Sciences for financing this whole workshop and conference, which my only complaint with them is that they could have provided one extra day for the conference so that we could have had a little longer break and time to breathe. And I hope they will take this suggestion next time from us. Somehow, with them being more physicists, they don't seem to understand that we need to write on blackboard, which takes time. So, and I would now like to thank all the student volunteers who are, I remember some names, so Mumukshu, Nisha, Tushar, Akshay, Chara, Priyanka, Anita, Kashish. I'm sorry I don't remember more, but I'm sure there are so many of them that at any given time you are in little trouble, look little bit confused, and somebody pops up saying, "Ma'am, what do you want? Sir, what do you want?" So I'm really happy they're putting countless hours of their effort in it. Then there is also Dhaval and Kamlesh. And I would like to thank local organizing committee, Haribhai, Ruchidas, Thomas, Ekta, and Sejal Shah. And all the students and faculty have put in countless number of hours to make this conference a big success. And they seem to have solved all our problems. Every time anybody had any slight thing, whether it's shopping or water or somebody falling sick like me, and very enthusiastically took out this second meeting with you, and I'm really happy that we could all meet here, and it's very nice. Now I would like to invite people from audience, if anybody wants to say anything, whatever. Just, yeah, I didn't take that long, so if anybody wants to say anything, you're welcome. I'll give you half a minute to think over it.
Especially some physical comments. Well, I think we should all thank Reedy as well.
My role was minimal. I was kind of trying to keep away, not available most of the time. So,
I just want to make one device in his first talk. But why in Baroda, many people have asked me and I have had no answer. The only answer that I could say is that because Valedictory is here and he has to answer that. So he has not only been been responsible at every stage, conception, execution, and all the arrangements and everything. So I thank him very heartily for organizing this event. I'd also like to thank all the faculty and students and everybody who supported, also the university and everybody who supported. And I'd also like to take this opportunity to thank François Latrapier, who did a valiant and marvelous job of explaining some of the things which I thought I was understanding for the first time. Lenin-Strauss, I think, in fact, took up the task at more or less 11th hour, and in spite of that, he really captured some of the very important issues which I felt had not come to the fore in some way, and I would really like to thank you for the subtle points that were brought up. Thank you. And thank you all.
or does anybody feel that they haven't talked during the conference?
Some critical.
Okay. Tarun Das is very, very serious that he wants some critical comments so that next time he also...
Like they were last time.
Oh, that. Before they took me in the organizing committee, he asked me whether I had any critical comments. So I had a long list of them and I had to talk about them. So then they said, fine, now you'll be in the committee, so. But to their credit, they have taken care of it wonderfully. Like they have a very nice computer room. Last time they had fewer computers and most lectures were CC beta, so it was a problem. So whatever I had heard from participants, I passed on without a care in the world. Little did I know. Anyway, but they did a very good job, and seriously, if you have any comments, suggestions, you are free to either say here or just send him a quick message or quietly whisper in your ear. He would be very happy. They really welcome the suggestions and comments. So, because sometimes things don't occur to the organizers and the participants, because they want to do things. Okay? So, I suppose it's not coming here. So, you want to say something?
No.
So, now I would invite Professor Das to say a few words. I think, would have the last words.
Thank you. Professor Dani has given me a problem. I must explain why Baroda. Actually, it was myself and Ravi. We were actually pondering upon that we should have another event. And I remember Nerurkar, when he was here last time, he was emphasizing that such event will be regularly held. And then they came upon that we really had a difficult situation last time because of the funding agencies. So we thought if we can fix only one agency from where we can get the complete funding, and therefore But soon, while we were discussing this, we realized that Professor Gandhi is completing 65 years, and I have personally known him since I attended my interview at TIFR, and since then I had great regards and respect for him, for his work. Though very rarely I used to meet him, but I always admired his work, and I thought this is the best opportunity to do something in his honor at this department. And that is how this thought came into my feelings, and I'm very happy that it took a shape and it is concluding, and I think it is concluding in a just way. So I hope you all will agree to that. And I'm very grateful to all the speakers, honorable speakers, those who have contributed immensely, and it's a great honor to have all of you on this floor, this department, to lecture before some of the future budding students, mathematicians. I will be very happy if even one or two turns up and do match to this quality of research. And I hope and wish to all my students very best that they must have been inspired by this series of lectures and coursework. And not everybody gets Fields Medal, not everybody gets Nobel Prize. Though many of us feel like we have worked at that level. I'm personally grateful to you for making it to this department, and our university is very grateful for that. And I wish you all a very happy and safe journey back home. And I wish you a very fruitful and eventful year coming soon, 2013. I hope you all and your family and everyone lives in a very enjoyable and fruitful and nice manner. And hope to see you all somewhere, someday, in some event. And wishing you all the very best. Thank you all for coming. One of those few mathematicians in the entire century who have been awarded this Fields Medal, and it's a pleasure and proud moment for all of us. I thought it is a good idea, as was expressed by some of the students and even colleagues, that maybe we can have an informal meeting with him. I'm thankful that he has very kindly agreed. I request him to share some of his things, and then the house will be open. If you want to ask something, discuss. It's up to you all.
But I think what we have done, which organize bring mathematicians throughout the world to use some of Simon's theory is very important thing. So when you are in a place with a relatively small mathematics department, which valiantly tries, despite very heavy teaching load, to keep some research going, but still it's quite hard to see what's going on in the world. I think this is a very great opportunity that already twice has happened here. Mathematicians from throughout the world come here. We've seen, for example, in the problem session, we've seen all sorts of nice problems, which I guess, unfortunately, it's probably, despite these efforts, it's probably good ideas for people to try to see what's happening, maybe follow a bit what's publishing the leading journals, see a little bit, maybe run starting working on as a graduate student, I started working on problems which are quite different from the problems I work on today. I was working on problems in abstract Ergodic Theory, abstract Dynamical Systems. Are quite nice problems. They still active. They still and the problem I was interested in is suppose that dynamical systems, maybe X is a complex kinetic space and with homomorphism, you could ask when you can embed it in various things you could ask when you can embed it to so this might be a big system, infinite topological entropy, infinite dimension, infinite anything. You could ask when you can embed it in for instance, shift or an interval. This is related to various other interesting questions. I guess at some point during my working on the thesis of complete Java, I was sort of learned a bit of this, learned about this beautiful problem of Fürstenberg, which did appear here at least in the problem session. So Fürstenberg studied, if you look at essentially the unit interval, if you glue it in the end, and you look at the maps which take x to twice x mod 1. And we have mod 1 these two maps. So they commute our nice maps. So Fürstenberg showed that any closed set invariant under both of these transformations has to be everything or finite. If there was conjecture, I have been thinking of on and off since I was a student, and other people have been thinking about on and off since longer. But then invariant measures on V with no atoms. Is the big measure. So this is sort of the tip of an iceberg of a nice collection of problems which I then started studying with Barak Weiss when we were both graduate students. We started studying flows and homogeneous spaces, particularly started studying another question that I'm still thinking of on and off, maybe more on and off since then. So we could look at so maybe this is a space of lattices in R3. Volume 1. And of course, maybe you could any linear transformation which preserves the volume. So any matrix, so any matrix in SCR takes you can multiply it with applying to every element of the lattice, you get a new lattice. So it acts on the space. There's a lot of conjectures, it's just notations. So the conjecture, if you have a lattice, if this is a lattice inside the space of lattices in R3, and A is a group of diagonal matrices. So a group of diagonal matrices, of course, determinant 1. then you want to show it in some sense. So if you think about it, this is a two-dimensional group, but you have here three missing lattices diagonal, so but determined as we want, it's a two-dimensional group. Abelian, it's a bit like this times 2 times 3 question. So maybe you could hope that something like this, what phenomena Furstenberg discovered, this times 2 times 3, this would hold here. It's actually quite an old conjecture, older than this is a conjecture which dates to the 50s, but not this formulation that any okay, if lambda is continuous from what I wrote here, and the conjecture is that a lambda, if this orbit is bounded, if this is not periodic, if it doesn't close up on itself, this orbit, then it's unbounded. If we have Barak and I have paper on this problem, which I think sort of, at least for me, that's the way I can learn new subjects, is by working with someone on the problem of the subject. It's sort of hard to learn passively, at least for me. Some people are better at this than I am. So we were working on this problem while babysitting perhaps little children who are now 18-year-old. Anyway, so I guess then this format, when I'm sort of here on this side, everyone's there on that side, is probably not the best format for intimate discussions, but anyone wants to say something.
Actually, he described, how he started reading. He was given a model where he really got into the subject. Later on, he really pursued it. He started with this simple case and then he went into how to get into something very serious. Yeah, but as he says, was everybody on one side and he on the other side doesn't make sense. So, yeah, I would request somebody to have some specific things or.
So everyone here is not everyone is post-faculty and
Shilpa, Vikubai, Kamlesh, and of course Ruchi is there, and Ekta said that they are also colleagues, and 2-3 members are not here. One is on leave, and Haribai is there, and Nawal is there on a temporary teaching assistant. Sharad is also there. Where is Mamta? Master's students, some of the undergraduate students are. Anybody from final year graduate student? BSc final year. Anything you want to? You must be pondering upon what anything. Yeah? Yes, Roshani, you want to ask? Yeah? Loud.
Sir, can you please tell us something about your film?
Maybe they want to know when you got the news or something, I don't know.
so it was an unusual experience. I mean, somehow this has got some real media attention, so first time in my life I had to talk a bit with journalists. Thankfully, somehow in Israel, there was a brief period where people were excited to speak in Israel, but very few people somehow forgot all about it. So again, I'm completely anonymous.
Comfortable.
And he somehow told me the difference between the master's course in US and the master's course in UK. So he said in the UK you have to come up with something specialized and you have to take up the master's course, whereas in the US you have many options from which you can slowly get into something specialized. So which one is better according to you? If
So I don't really know. So it's one of the things. The US there's no such thing as masters. So US you have your undergraduate, and then you would typically go to graduate school directly to PhD. And at least in Princeton, the way it works is the first year when you are in graduate school, you're basically done by yourself. Or maybe there are courses, but basically you're supposed to learn the basics. And then you start, after you sort of pass some qualifying exam, you get this certificate that you are ready to research, and then you somehow start talking to an advisor and start thinking of a problem.
for the PhD. For the PhD.
For the PhD. So basically, master's degree is not something that they have in the US. In Israel, actually, there is a master's degree, sort of. It basically serves. For one thing, it's also this period of time where you're supposed to learn the basics of what something that everyone who's practicing mathematician should know. You do some small research project which maybe would lead to if it's a good research project, it would lead to one paper in some journal, sometimes it doesn't. And after that, after you finish your master, you are supposed to be almost immediately able to start researching as a PhD. Now, I'm not quite sure how this system works here. It might be different also from place to place, and maybe we talked a bit with Nimish about how it's done in TIFR, but that's somehow not the...
Even in TIFR and in here, there's a difference. So actually, there is a semester system. Each semester they have to study about 6 courses, and they have now we are able to introduce dissertations. They can choose a topic and write a dissertation. But for students who are scoring say 60% and above, so they get the opportunity to write a dissertation, and maybe hopefully they can pursue it later. There are, of course, in the last 2 semesters of our master course, we have elective papers, optional papers they can choose. Like there are about 8-9 papers. So they can choose Fourier analysis, they can choose special function, they can choose topological dynamics, ergodic theory, and so on.
And students who want to continue to be a mathematician, they would continue here, or they would go elsewhere, or
They have a choice, The first thing is that they must get some scholarship. So there is a test at the national level being conducted by the University Grants Commission, and if they pass, then the thing is that they can choose a center of their own choice and a person of their own choice, and they can approach, and then they can get registered. And there are, of course, other funding agencies giving fellowships for National Board for Higher Mathematics and some other places.
yeah, but it's somehow completely global, and it's throughout big India. You could go to any...
Yeah. But usually what happens is, they use their own references and their, of course, acquaintance, they come rather than going to a very unknown place. So obviously that gives some kind of motivation to join an institute or a person.
When is this exam?
This is held twice in a year, usually in the month of June and in the month of December.
Did you say allowed to go to the exam twice, or just once, or how does it work?
They can give it in number of times.
You also face that kind of...
Yeah, to some extent. I mean, I was So my undergraduates, I still studied both physics and mathematics. Somehow both were interesting. And more or less when I finished my undergraduate degree, so when I finished my first degree, I decided to go more seriously into mathematics.
Did some of the specific courses influenced you, or at the undergraduate level, or it was just overall?
Well, definitely, I had I made a very wise choice of advisor as a master's student, choosing Benji Weiss. That was certainly, I mean, that's a very important decision somehow.
Yeah, that is very important.
And this has certainly helped me decide to be a mathematician.
Which mathematician highly impressed you?
Which?
Mathematician.
Many other questions somehow. There are many people who request me that I work with. That's actually one of the good things of being a mathematician, that you actually meet quite a few impressive people. I learned a lot from many my colleagues, of course. Like you see here, so I was definitely, my research is very much influenced by Furstenberg, very much influenced by Benji Weiss. I went to Princeton and I learned a lot from Peter Sarnak. Later I learned a lot from Bourgain. I worked with Akshay Venkatesh and learned a lot from him. Long-term collaboration with my friend Manfred Einsiedler. There are many people I learned a lot from. Shah is somebody I've learned quite a bit from. But on the one thing you see that, which is a bit sad to me, you have many excellent Indian mathematicians, but not all of that sort of maybe more of Indian origin, mathematicians of Indian origin, less somehow you would expect from a country this large with so much talent to produce more mathematicians. And you see what the top, if you look at the top mathematicians in the world, India is well represented. It's sort of like you expect to see more research done in top level research done in India than you actually see.
I guess that is quite influenced by, because in school people want to go into engineering, so no one wants to go into basic sciences. So for example, from my class, I'm the only one who's into basic sciences. So everyone wants to go into engineering because I guess driven by, say, you get a job and everything, you have to do more hard work in this field. So I guess that is one reason, according to me, I think.
Yeah. Or if you look at it sort of logically, then your chances of getting a good salary and good opportunities are higher than pursuing some career in the high-tech industry.
Your daughters would like mathematics? You want them to be mathematicians?
Well, they're still small. The definition of mathematician. Probably someone who does mathematics for its own sake, not because it needs it in order to do something, just because it enjoys it.
But it should be some level. Up to that level, it will become, a person become mathematician.
one thing I'd like to see in paper that I read or somebody can talk, I'd like to see some new idea, not just somehow extending a bit what was existing. I'd like to see new ideas. That's somehow really good new ideas are not so easy to come by.
Do you mind what the exercise is? What kind of picture research is you have to solve some serious differential
What I
in field medal, what they require is what they emphasize is.
Yeah. The main thing I've worked on is this kind of multi-dimensional actions on homogeneous spaces. Among other things, I somehow was able to make some progress. So, like you see, in some sense, the problems that I started with when I was working on my PhD are still open. So the main things I wanted to do, I still haven't done. But on the way, somehow, I think it's actually a good thing. So I have these maybe conjectures which are still far away, but then on the way, you see, you are able to make some advances. So I was able, with colleagues and friends, I was able to make some progress toward understanding these actions. I was able to connect them to questions that people thought are not related, like eigenfunctions of the Laplacian on certain surfaces. I was able to deduce some interesting information about eigenfunctions of the Laplacian surfaces from this kind of circle of ideas. That's among the things that I was able to do with this kind of technology, with most of it, not all of it, most of it in collaboration with other people. Apparently, there were the wise people in the committee, that was enough. Mathematics is one hobby. And family is nice, and playing with the kids is nice. But not too much time beyond that. Like music, for instance. One thing I've noticed when I that I was somehow less productive always in the office than I was at home. And after analyzing why it was because at home I worked listening to music in office, especially so it wasn't so bad in Jerusalem. When I came to the Institute of Advanced Studies, I don't know if you know the Institute of Advanced Studies in Princeton, but it's sort of a very intimidating place. There are these lots of young people, sort of postdocs from all over the world, and then there are the most famous mathematicians, this sort of superstar. It's a slightly intimidating environment. At some point, I realized that if I won't listen to music, I won't be able to work in my office, despite the danger that I might. I'm not going to be able to listen to music in the office. Like everyone, I know what it says, but I don't have a feeling for it in my language so much. A bit I do, but it somehow, so I don't, in some sense it's not a problem that I feel very well. In these problems I feel very well. But the Riemann hypothesis is not something that I feel sufficiently intimate with somehow at the moment. Say something intelligent. This is complicated. I submitted the series, that's easy to say 99, but in Israel, I don't know, but in Israel there's mandatory military service and somehow there's some delay in the things. It's not so easy to say exactly how much time it took.
He was discussing the level of mathematics in India. And what Professor Levan said, actually, in some sense, he was saying a similar thing. Professor Raghunathan remarked that the mathematics in India is very good and not very good. Then he wanted an explanation that what it really means. And he said that he was in some sense comparing with China also. He said when it comes to quality mathematics, top level, India is there, which he actually said. He also then mentioned Venkatesh and many others are there. But then he said that, so there we are, he said, probably we are much better than even China. But when it comes to the medium spectrum, we are not there. There China really supersedes us. So it's a matter of concern, and it's a matter of concern. I think you all are in that age group when you can appreciate this concern. You all are Indian, you are all are voters in India, and anybody who can vote and elect a government is duly recognized to have a good level of thinking process. So it's a matter of great concern. So I'm sure you all will do needful to address this in the next generation. What probably we have not been able to keep up.
I just wanted to ask, do government policies and the way they function can increase the way in which, any subject flourishes in a country, or no?
Yeah,
You have one more, anybody?
because usually you see it when the government does something bad and it sort of hurts such a country, but definitely, it's a delicate thing, research, and it's something which pays dividends, especially mathematically. It pays dividends only after a very long time. I don't know how things are here, but at least in the US and Israel, who have spent some time, the government seems to be planning ahead, maybe 1 week or at most. Long term means after the next election. You don't, mathematical research won't affect wide society until the next election. Definitely not true mathematics.
What trick you adopted the approach that to achieve this? You can give some guidelines to all of us.
Just somehow I work on problems that I somehow enjoy and find very appealing. It's very hard to work on a problem which you don't really like. There's something emotional about working on a problem. You need to work on a problem you like. Not using your full potential. It's actually, for me, it's very hard to read mathematics. Like I said, the easiest way to learn a new subject is to work with someone on a problem for me. But, okay, for good and for bad, when I try to read, usually when I see, let's say, a lemma or something, I try to see if I understand why it should be true and how to prove it before looking at the proof. Maybe that's one of the reasons why it's very difficult for me to read mathematics.
Anybody is ready parting after the question, or everybody is okay? So if there are none, then I, on behalf of department and
Thank you. It was actually fun discussion. I was a bit worried when everybody said here. I was here that there would be no discussion.
I hope this must have encouraged some of you and look up to you and your future, your relatives, your well-wishers. Make it. It's given you the mantra, don't shy. If you want to learn, you have to come forward. That is the mantra I believe is given. Thank you, Professor
दबाव पुश कर ऊपर आओ ऊपर खींचो रखना नहीं है
रेडी